7 months of salt water has transformed me. From surface oxidation to deep pitting in my alloys, the corrosion creates a new, thriving structure.
Wait a minute. That's not geological. It's structured.
The stealth coating is completely gone. Look at that galvanic corrosion on the stabilizers.
I think I have something here. Look at this!
Confirmed, 73 Charlie. That's the one.
Survey complete. Metal thickness measures below 0.1 inches. Critical corrosion at wing attachments risks catastrophic failure during lifting.
Here, these iron oxidizing bacteria literally eat the metal, secreting acids that dissolve the iron and aluminum.
The Pratt & Whitney F-135 engine is a solid mass of rust. The turbine blades, once
The salt water trapped in these sealed spaces created catastrophic corrosion. The missile rails are unrecognizable.
7 months in salt water. The systems are completely compromised.
We don't leave our aircraft on enemy territory, and the ocean floor is enemy territory.
The realization that rust has made the aircraft heavier. Iron oxide is denser than the original aluminum.
Look at the penetration depth here.
Yes, the dendrite patterns are extensive, almost like roots.
Estimate?
The estimated weight is 38,800 pounds. That exceeds the lift capacity.
The traditional points are too corroded. We can't use them.
Yeah.
So we distribute the load with this web design. See here.
And the redundant systems compensate if anything shears. It failed at 35%. That's catastrophic. We need to inform the recovery team immediately.
The aircraft needs to be moved to shallower water, but the metal is heavily corroded with sharp, unstable edges.
How do we attach cables to rust?
Oil is interlaced. The chemical penetrates the rust layers and creates temporary bonds, essentially gluing the corrosion together.
Cables secured and sensors calibrated.
Run the final diagnostic check and log the release mechanism test.
Seas are still too high, winds over 15 knots. We missed the window.
11 weeks until the next opportunity, Chief.
The water jets could cause microfractures.
Agreed, but the brute force lift requires accounting for the suction. The mud has it anchored like roots.
We are approaching the limit on the starboard wing.
Gauges are spiking. There it goes.
Record the fracture point data immediately.
Ensuring non-interference while maintaining confidentiality is paramount.
This wording achieves the necessary balance.
Try securing the cable clamp on that rib.
Copy that. Engaging the clamp now. It's crumbling, Supervisor.
Acknowledged. Be gentle.
We have structural failure. Wreckage breaking apart.
Deploying the net now. Secure the payload.
We have 17 distinct failure points. Any one of them could result in catastrophic loss.
Cast off all lines. Full speed ahead.
Aye, Captain. Lines are clear. All units hold the 5-mile exclusion zone. Roger. Maintaining station north.
This is Poseidon, commencing surveillance pattern.
Looking good. Steady ascent.
Wait, telemetry spiking. We have a separation on the aft section.
Sound the alarm. We are losing the payload.
Wing section torn free. We have a critical failure.
Calculations show stability, Commander. We are green to continue.
Acknowledged. Maintain course.
Visual on target. Jesus Christ, it's worse than the footage showed. Rust is... it's everywhere. Like, it's growing.
It's cracking. The fuselage is failing at the third cable. We need emergency reinforcement now. It's spreading too fast.
Confirmed airborne. Proceeding to recovery zone.
Cable system secure, Commander. Standing by for deployment.
Cable extending, steady as she goes. Divers, report status.
We have the harness. Locking shackle now. It's secure.
Keep the power steady. We're showing 32,000 now. 34. Watch the limits. We're climbing past 38,000 pounds.
Stress levels critical. We've had a structural failure.
Load just dropped. We have to decide now, sir. Continue or abort.
The stealth coating, it's gone.
And the barnacles, they're massive. It's unrecognizable.
The oxidation is accelerating. We need full coverage on the wings now.
Maximum pressure on the starboard side. Watch the drift.
Can this even be saved?
We got it, she's secure.
All right, teams, move in. Start the cooling sequence immediately.
We've got a new hairline fracture near the cockpit.
Copy that. Increasing stabilization flow to quadrant gamma.
We need more tension on that forward chain. I can't hold it. It's slipping again. Get that binder secured now. I don't care how you do it. This footage needs to be pulled immediately.
Sir, it's already everywhere. The hashtags are trending.
I've never seen corrosion like this.
It looks almost biological. How is that possible on an F-35?
Look at the density here. The oxide weighs 42% more than the iron it replaced.
That explains the 6,400-pound difference.
Oh my God, look at this. It's completely gone. The ribs are just lace.
I've never seen anything like it.
Look at this corrosion. It's completely seized. Data recovery is a bust. This entire system is a total loss, about 40 million to replace.
The topography scan confirms the extent of the exfoliation.
Absolutely remarkable. This data alone will advance corrosion science by decades.
We identified 16 different corrosion products, from simple iron oxide to complex compounds involving...
Check that out, 0.7 millimeters, 68%.
Incredible. Looks like we got a project on our hands.
I understand your skepticism, but this fiber laser technology allows us to vaporize the rust completely.
Option 3.
Option 3, the complete laser restoration, comes at a cost of $54 million.
It is absolutely essential.
This will prove American capability and determination. Most importantly, it sends a message.
It's working. Look at that. Incredible! We finally did it!
Aluminum needs one power setting, titanium another, and the areas where dissimilar metals join require precise control to avoid damaging the transition zones.
The pressure just blew the secondary seal on intake 7.
We're losing containment. Get the main scrubbers online now.
Power steady, keep the alignment perfect.
Holding steady. Look at that finish.
Flawless. We did it. Look at that, the original stealth coating. Incredible. And the squadron insignia is intact.
This section is compromised. We have severe pitting corrosion underneath the rust we cleaned.
Okay, I'll mark the boundaries for the patch weld.
I cannot believe this is the same plane. Look at the shine.
Wow. Yeah, it's incredible workmanship. The rust was so severe.
This photo is going straight online. The emitter is completely burned out.
We are looking at a 3-week delay.
Wait, look at this section. The metal is pristine, it's salvageable.
The aircraft's belly is the worst corroded area, having rested in sediment. The laser reveals metal so pitted.
After 3 months, the F-35 is 50% restored. 18,000 hours of laser operation, and we're finally seeing the results.
We can't salvage this section with the laser. The corrosion is simply too extensive.
Agreed. We need to document the degradation thoroughly before we replace it entirely.
The patterns confirm the water flow dynamics and the bacterial boundaries.
And the chemical gradients align perfectly with the corrosion prediction model.
Carbon fiber composite sections require completely different treatment. The development of lower power laser settings that remove corrosion.
The marathon laser session required to clean these complex spaces. Robotic arms work at impossible angles.
Look at the deformation here. It's clearly localized impact.
Consistent with the bird strike.
Here we see unique corrosion from previous heat stress and salt water. The laser reveals rainbow-colored heat.
The last pass is complete.
Absolutely stunning. Well done. Congratulations, team.
Okay, bring the softbox slightly lower on the port side.
How's that angle looking?
Perfect, hold it right there.
The assessment is complete. Structurally sound for display, 82% of the original airframe preserved.
It's better than we hoped. She won't fly, but she'll stand proud.
The laser precision is remarkable, vaporizing the rust without altering the substrate.
It looks brand new, just like the day we flew her.